We're going to have a look today at how to create FM synthesis and find out really what FM synthesis is, and it's something I would like you to incorporate into your composition projects this year. So FM synthesis stands for frequency modulation synthesis, and you might have heard that word FM before, used in other contexts like radio broadcasts, for example. I think Radio 1 is broadcast on 99.3 FM. So radio kind of uses a similar method to broadcast analog radio. It's a bit different with DAB, digital radio, but that's another topic altogether. So frequency modulation synthesis is different to what we've looked at previously, which has been predominantly subtractive synthesis. Now, subtractive synthesis is a method of creating sounds using oscillators and then creating a rich timbre and then filtering out the various sort of harmonics and things from the sounds using filters and envelopes and stuff like that on a synthesizer. But on a FM synthesizer, it's a slightly different process that you go through to create a new sound. So the important thing to just kind of be aware of with frequency modulation is that there's really two fundamental aspects to it. There's something called a carrier signal, and that's the thing that you hear. And then there's something called a modulator signal. And you don't hear the modulator, but what happens is the modulator has an effect on the carrier that you hear. So it's the modulator that changes the sound of this carrier signal. So to demonstrate that to you, I'm going to try and use a synthesizer that we're familiar with, the ES2 synthesizer here. So an example of really basic FM synthesis. I've got a sine wave here, and I could use a LFO, a low frequency oscillator here, to modulate. So this is my modulator, this is my carrier. I can use my LFO to modulate the pitch, or therefore the frequency of this sound. And we've heard that kind of thing before, but let's demonstrate. So I'm going to affect the pitch of oscillator number 1. I'm going to use LFO number 2, and we're going to wiggle it up and down. So essentially what I'm recreating here is very, very simple FM synthesis, but it's not really the kind of FM synthesis that we want. We want to go one step further than this. So I can increase this and it gets faster and faster. Now this LFO, this is a low frequency oscillator. If I turn it up full, you'll notice it goes up to 20 hertz there, which is almost into the audible range of what we can hear as humans, but not quite. So this is below the frequency range. That's why it's called a low frequency oscillator. We can't actually hear this, but we can get faster and faster until it sort of sounds like it's really wobbling the frequency in a really kind of fast way. Now FM synthesizers, what they do is this same kind of process, but this second oscillator here actually it's within the audio range, and when you take this up beyond 20 hertz, really strange things start to happen, because when you start to combine the two oscillators together, and they start to create new frequencies, and that's what gives you a new sound, a new synthesized sound. So I can kind of demonstrate it here by putting on another oscillator. We've got an FM control, so I'm just going to turn this off for a second. So what I'm going to do is I'm going to increase this FM control, and that is going to start using this sawtooth wave here as my modulator. Okay, so you can see here it sort of makes a much thicker timbre, a much sort of stronger sound as well. What we could do is we could see what effect that has on the actual frequencies within the sound. So if I just take this back to a simple sine wave, we put an EQ on this, we'll have a little look. We can see here one frequency, and then if I start to increase the FM, there we go, you can see all those extra harmonics and extra frequencies that have been created. So I haven't done this by adding different oscillators as such. What I've done is we're literally just hearing the carrier here, but we're hearing the impact of this modulating that. So it's modulator altering this carrier signal here, and that's what's giving us a richer sound. Now, you can end up creating some really cool sounds using FM for synthesis, and in fact, inside Logic, if you go to your drop-down instrument menu there is an actual FM synth, which I want you to load up and have a play around with. So, let's get rid of this, and let's open up the EQ again. Now I've just set this up, so what we can see here is carrier, modulator, and an FM control to blend the two together and get the modulator modulating the carrier to create all sorts of cool effects. So I've really kind of simplified this down, so we're listening to one frequency, and we're just listening to the carrier on its own, no FM, no blending of these or anything at the moment. So I've literally, as you can see there, one frequency is pretty much a sine wave, and this is the carrier that we're hearing. I can add in extra harmonics if I want. I can go up to 2. We are now hearing the second harmonic of the weight of the sound. And the third, fourth. Okay. And then over here, this is my modulator. I can change the wave shape of the modulator. It can be a sine wave, or I can just sort of filter through different wave shapes to give all sorts of interesting new harmonics. Let's just increase this a little bit. There we go, and you can start to see now the effect that the modulator is having on the carrier in creating these new frequencies that are appearing. And if I increase it more, just like what we saw on the other synth, enriching the timbre. And it sounds completely different to subtractive synthesis. These FM synthesis typically used for things like lead sounds, bass sounds, but also creating weird things like whistles and bells, which are really difficult sounds to create on a subtractive synthesizer. So you can use FM to create those weird kind of bell-like sounds and I describe them as hollow sounding sounds, but they also work brilliantly for bass lines in electronic music. You can increase the number of harmonics within the modulator. Change the wave shape of the modulator. Once you really start increasing the FM depth, the number of harmonics on the modulator, you really start to get a very rich timbre. It's got loads of frequencies in it, and it sounds really thick and cool and aggressive sounding. So it can work well with leads, work well with bass sounds. So I want you guys to make sure you incorporate an FM synth of some description, whether it's the bass part of your composition or a lead instrument or something like that, or a solo or something. Have a go at creating your own FM sound, and then describe how you've done that using a carrier and modulator and the settings that you've applied. Cool, that's it.